Mars, the red planet. For millennia, humanity has gazed up at the stars, wondering if we could ever step foot on another world. Mars, with its stark beauty and tantalizing potential, has captured our imaginations like no other. Over the last few decades, we've taken monumental strides toward reaching it, from robotic rovers exploring its surface to missions that are planning to send humans there. But making a Mars base a reality is more than just sending people to the planet. It's about creating a sustainable, thriving colony that can survive the harshest conditions the universe has to offer. The question is, how do we do it? Building a base on Mars isn't just about construction. It's about creating an entirely new way of living. The challenges are immense, but so are the rewards. Imagine a self-sustaining base where humans live, work, and explore. It's not just a dream. It's a goal within reach. But before we can get there, we need to answer some critical questions. How do we keep people alive in a place where there is no breathable air, no liquid water, and temperatures that can drop below -100 degrees Celsius? How do we build habitats that will stand up to the Martian environment? How will we power our base and travel back and forth to Earth? Let's start with the most fundamental element, life support. The environment on Mars is unforgiving. The thin atmosphere, composed mostly of carbon dioxide, offers no breathable air. Temperatures swing dramatically, and deadly radiation from the sun bombards the surface. Without robust life support systems, a Mars base wouldn't be possible. These systems will need to handle everything from recycling air and water to providing food. Hydroponics will be a key element in food production. On Earth, we rely on soil for growing crops, but on Mars, we'll grow our food without it, using nutrient-rich water to nourish plants. These crops won't just provide food. They'll also help regenerate oxygen, making the environment within the habitat more livable. By growing plants that can thrive in controlled environments, we're not just feeding the crew. We're creating a sustainable ecosystem that will support human life. Water, as you might imagine, is another critical concern. Mars is a dry planet with no large bodies of liquid water. However, beneath the surface, there are vast deposits of water ice. The challenge is extracting this ice and turning it into usable water. Specialized filtration systems will be required to purify the water, whether it comes from underground reserves or is recycled from the habitat itself. Every drop will be precious. And that means that recycling will be the backbone of the life support system, reusing water from food production, wastewater, and even human waste. It's a closed-loop system that will need to be incredibly efficient to ensure survival. Next, let's talk about the habitat itself. Constructing a safe, durable, and efficient living space on Mars will be one of the greatest engineering feats of our time. The Martian surface is exposed to constant radiation and extreme temperatures. In order to protect astronauts from these dangers, the habitats will need to be well shielded. But here's the challenge. Sending materials from Earth is expensive, and building a base with Earth-supplied materials could take years. Instead, we'll need to use the resources Mars provides. Mars has abundant regolith, the loose, powdery rock that covers much of its surface. Regolith contains key elements like silicon, iron, and oxygen. Scientists believe it could be used to create construction materials like concrete or even bricks. This concept is known as in situ resource utilization, ISRU. By using materials directly from the Martian environment, we can cut down on the need to transport heavy materials from Earth. In fact, we could use ISRU to create habitats, roads, and even protective walls made of Martian materials. Imagine a 3D printer capable of printing buildings layer by layer, using local resources to build the base from the ground up. Robotics and automation will be key to building these habitats. Before humans even set foot on Mars, autonomous robots will be deployed to prepare the land, dig into the Martian soil, and begin constructing the base. This robotic workforce will work tirelessly, laying the foundation for human arrival. By the time astronauts land, the first structures could already be in place, providing shelter and resources from day one. Now let's talk about transportation, getting there, getting around, and getting back. Right now, one of the biggest hurdles to reaching Mars is the vast distance. A typical journey takes anywhere from 6 to 9 months, depending on the positions of Earth and Mars. That's months of travel through the harsh environment of space. To make this possible, we need spacecraft that can carry large amounts of cargo and crew while withstanding the extreme conditions of space. Companies like SpaceX are developing new spacecraft designed for long-duration missions. Their Starship, for example, is a fully reusable spacecraft designed to carry both crew and cargo to Mars. Once on Mars, astronauts will need surface vehicles to travel around the planet's surface. These rovers and transport shuttles must be able to handle the rugged Martian terrain, deep dust storms, rocky hills, and extreme temperatures. Mobility will be a key factor in the base's success, allowing astronauts to explore, collect resources, and carry out experiments across the surface. On Mars, there's no electricity grid to plug into. The planet is farther from the sun than Earth, meaning solar energy is weaker. But with the right technology, solar power can still be an effective energy source. Large arrays of solar panels will collect the sun's rays and convert them into electricity to power the base. However, we'll also need to store this energy for the long Martian nights, which last about 12 hours longer than Earth's. In addition to solar power, nuclear reactors could provide a reliable, round-the-clock energy source. Compact, safe nuclear reactors could provide a constant energy supply, crucial for powering life support systems and keeping the base operational. It's not just about generating energy for light and heat. We'll also need power for critical systems like water extraction, air purification, and communications with Earth. One of the most exciting prospects for building a Mars base is the ability to use local resources. Mars has vast reserves of water ice beneath its surface. By mining these resources, we can produce water for drinking, growing crops, and generating oxygen. Even the Martian atmosphere, mostly made up of carbon dioxide, could be processed to create oxygen for breathing and even methane for fuel. In the future, we could rely less on shipments from Earth and become more self-sufficient. The ability to mine and process water ice on Mars is crucial to long-term sustainability. But beyond water, Mars is rich in other materials, like metals and minerals, which could be extracted and used for construction, manufacturing, and even creating fuel for return missions. The more we can use Martian resources, the less we need to rely on Earth, reducing costs and increasing the feasibility of a permanent settlement. Even with all these advancements, there are still significant challenges. One of the biggest is radiation. Mars lacks a magnetic field like Earth's, leaving the surface exposed to harmful radiation from the sun and cosmic rays. This radiation can damage human cells and increase the risk of cancer. Shielding habitats with thick walls or using Martian soil to cover them could protect astronauts from this deadly radiation, but it remains one of the toughest obstacles we must overcome. Isolation will also be a psychological challenge. Astronauts will live in a confined space, cut off from their families and friends, with little contact with Earth. The psychological impact of such isolation can't be underestimated. Teams will need to be trained in mental resilience, and habitat designs will need to include spaces for relaxation and social interaction.